Very pleasant good morning to you all. I welcome you all to the physics online class. Last class, you all marked fourth lesson up to the numerical problems, isn't it? So the remaining Hart's answer we are going to mark today. Okay. So here 3 questions are there, problems. You have to take your classwork note and copy down the first problem. Okay. Fourth lesson, again we have to mark the Roman letter 11, isn't it? Hart's answer. First question, two resistors when connected in parallel give the resultant resistance of 2 ohm. But when connected in series, the effective resistance becomes 9 ohm. Calculate the value of each resistance. Here they asked two resistors connected in parallel. The effective resistance value is here. How many ohms? It is connected in parallel, gives the effective resistance or the resultant resistance is 2 ohm. We have to find the individual resistance. That is, two resistors means R1 value and R2 value we have to find. Okay. And if it is connected in series, the effective resistance is 9 ohm. Here also they given in series the effective resistance they given. So we have to calculate the individual resistance value. That is R1 and R2 value we are going to calculate. Okay. First here we have to write the given data. Okay. The resistance in parallel, what they given? 2 ohm. The effective resistance in series is 9 ohm. What we are going to find? The value of each resistor. Okay, the individual resistor value, that is R1 and R2 we are going to find. Okay, so first you have to write the resistors in parallel. What is the formula we learned? Have you remember? Resistors in parallel 1 by Rp is equal to 1 by R1 plus 1 by R2. Okay, that formula first you have to write it. 1 by Rp is equal to 1 by R1 plus 1 by R2. Okay, now this Rp value what they given here? 2 ohm. Okay. So the value of Rp is 2 ohm. So 1 by Rp value what we have to write? 1 by 2. Okay. So this Rp value have to write 2 is equal to 1 by R1 plus 1 by R2. Okay. Now here we have to take the LCM for this 2. Okay. That is, what is the LCM for this R1 and R2? Okay. So what's the LCM? R1 into R2. Okay. So R1, R2 here you have to write. Then here the numerator what will come? If you are taking this R1 and R2, here R1 is there. R2 is not there. So you have to write here R2. Okay. R2 plus R1. Otherwise you have to change it and write it R1 plus R2. Okay. So 1 by 2 is equal to R2 plus here R1. Okay. The denominator what will come? R1 and R2. Okay. Just interchange and write it. So R1 plus R2 divided by R1 and R2. If you want, here one more step also, here you have to write it. Okay. Next what we are going to do, you have to take, this is equation number 1. Okay. Now resistors in series. Okay, the total effective resistance in series, what they given? 9 ohm. And what is the formula for this resistance in series? Or S is equal to R1 plus R2. So we have to write that formula. In that we have to substitute the effective resistance in series, that is 9 is equal to R1 plus R2. Okay, then you have to take any one of this value here. Okay. That is 9. First you have to take this R2 this side. So this plus, if you are taking this side, it will become minus. So 9 minus R2. Otherwise you can take 9 minus R1 also you can take. So if you are taking 9 minus R1, you can get the value of R2. Otherwise, if you are taking this R2 value here, we can get the value of what? R1. Okay. So here I am taken this R2 plus R2. If you are taking this side, it will become minus. So 9 minus R2 equal to what? R1. This is equation number 2. Now we got this value of R1, isn't it? So this R1 value we are going to substitute in the first equation. So substitute equation 2 in 1. Okay, what is equation number 1? Already we written equation number 1. What is that? 1 by 2 is equal to R1 plus R2 divided by R1 into R2. So in the place of R1 we have to substitute this value. Okay, so here what we got it? R1 is equal to 9 minus R2. Okay, that value in this first equation we are going to substitute. So 1 by 2 equal to, listen this equation, 1 by 2 is equal to R1 plus R2. So in the place of R1, what we have to substitute? 9 minus R2. Okay. Then plus this R2. Okay. That R2 here you have to substitute. Divided by, again R1 into R2 is here, isn't it? So this R1 value, again what we have to substitute? 9 minus R2. 9 minus R2 into this R2. Okay. So 9 minus R2. Where and all R1 value is there? There you have to substitute 9 minus R2. Now we can see 9 minus R2 plus R2. So this minus R2 and this plus R2 will become cancel. Okay. So divided by 9 minus R2. In the place of R1 what we substituted? 9 minus R2. So 9 minus R2 into R2. Okay. So it is equal to, here LHS side what is there? 1 by 2 is there. Is equal to 9. The remaining term cancelled. So remaining what is there? 9. Divided by this you have to multiply with this R2. Okay. So 9 into R2. 9 R2 minus R2 into R2. What's that? R2 square. Okay. So 9 R2 minus R2 square. Next just you have to cross multiply it. Okay. So this denominator value just you have to take in the numerator. Okay. So 1 into 9 R2 minus R2 square is there, isn't it? So you have to take this side. Okay. So it is in division. You have to take in this side multiplication. So 9 R2 minus R2 square is equal to this 2 you have to multiply here. Okay. 9 2s are 18. So, okay. So how this equation will form? 9 R2 square 9 R2 minus R2 square. Okay, 9 R2 minus R2 square equal to what? 9 2s are 18. Okay, so 9 R2 minus R2 square is equal to 18. Okay, now you have to change this equation in the algebraic equation form. Okay, so that is R2 square minus 9 R2 plus 18 equal to 0. Okay. So how means this one we have to take all these two term, take this side. So minus term will become plus. Here what is the minus term? R2 square, isn't it? This minus R2 square, if you are taking this side, it will become plus. So plus R2 square. Okay. Then this plus 9 R2, if you are taking this side, it will become minus. Okay. So that is minus 9 R2. Okay. Again this plus 18 is this side only now. So plus 18. Okay. Equal to 0. Okay. Don't confuse this one. Okay. This two terms just you have to take this side. Okay. So we have to change this in this equation form. R2 square minus 9 R2 plus 18 equal to 0. Okay. Next we are going to equate this equation. That is how to do. R2 square minus, so this 9 R2 it is there, isn't it? So here first you have to take this 6 3s are 18, isn't it? 6 3s are 18, and if you are adding this 6 and 3 you want to get 9, isn't it? So you have to select the two number like that. Okay. So if you are multiplying means you will get 18, and if you are subtracting means, adding means you will get what? 9. Okay. So minus 9. So what are the two numbers? What are the two numbers? 6 and what is that? Minus 3. Okay. So we have to change this equation like this. Okay. So minus this minus 9 R2 we have to take minus 6 R2 minus 3 R2. Okay. So minus 6 minus 3. What's the answer if you are adding? Yes, minus 9 R2 will get. Okay. Now this equation how we can change? R2 square minus 6 R2 minus 3 R2. Then what is there? Plus 18 equal to 0. So in this above equation, R2 we can take commonly outside. Okay, for this R2 if you are taking outside, remaining one R2 is there. That one you have to write R2 minus 6. This R2 already we have taken outside. Okay, R2 minus 6. Okay, then here minus 3 had to take this 3 outside. Okay, this minus 3 if you are taking outside, remaining what is there? R2 is there. R2 is this minus we are taken outside. So here what we have to write? 6. Okay, so already here 3 we are taken outside. So remaining what is there? 6. 6 3s are 18. Okay, so R2 minus 6 equal to 0. Okay, now for getting this R1 and R2 value only we are taking like this. Okay, so if we are getting R2 minus 6 equal to 0, then remaining one equation R2 minus 3 equal to 0. So you are getting two equation here. One is here same, isn't it? R2 minus 6, R2 minus. So R2 minus 6 equal to 0. Okay, that is one equation. Then R2 minus 3, R2 minus 3 equal to 0. Okay, so from this two equation what value we can find? Here we can get this value of R2. What is the value of R2? R2 is equal to this minus 3 if you are taking here, it will become plus 3. So R2 is equal to plus 3 we can get. Here what is that? R2 is equal to, yes, 6. Okay, this minus 6 if you are taking here, it will become plus 6. Okay, so R2 is equal to 3 ohm and R2 is equal to 6 ohm. Okay, so like that two value here we are getting. Okay, now substitute both the values in equation number 2. Okay, we are going to substitute this value of R2 in equation number 2. Okay, what is that equation number 2? Have you remember what equation? 9 minus R2 is equal to R1. So this is that equation 9 minus R2 is equal to R1. Okay, first here we got this value of R2 is equal to 3 ohm and R2 is equal to 6 ohm. These two values here we can substitute. Okay, so first R2 value is 3. So 9 minus 3 we can get 6 ohm. Okay, so R1 value we are getting now 6. Next if you are substituting R2 value is 6, what we can get? 9 minus 6. 9 minus 6 is equal to 3 ohm. Okay, so the value of R1 and R2 we are getting now. Okay, so the value of R1 is equal to 6 ohm and this value of R2 is equal to 3 ohm. Okay, so here the value of R2 is equal to 3 ohm and R1 is equal to 6 ohm. Okay, and if the value of R2 is equal to 6 ohm means R1 is equal to 3 ohm. So the value of R1 and R2 is equal to what? R1 is equal to 3 ohm, R2 is equal to 6 ohm. If R1 is equal to 6 ohm means R2 is equal to 3 ohm. So these are the two individual resistance value. Okay, have you all understand? I hope first question everybody copy down in the note. Now you have to do the second question. Okay, see whenever you are getting this problems you have to be copy down in your notebook. Okay, it will be useful for you. Don't see the guide and memorize everything. Okay, so you have to go through your note and if you are doing once it will be easy for your exam. Okay, so you have to be do it and write it. Okay, the second question, listen. How many electrons are passing per second in a circuit in which there is a current of 5 ampere? Okay, how many electrons are passing per second in a circuit? Per second, for 1 second how many electrons are passing? And that time what is the current? 5 ampere of current. Okay, when the 5 ampere of current is passing through the circuit, how many electrons will be passed per second? Okay, that is the question. So very simple question. First you have to write the given data. Okay, so from that question when you are reading how much amount of current is passing through the circuit? 5 ampere of current. So I is equal to, you have to write 5 ampere. Okay, per second they asked. So time is equal to what? 1 second. Okay, so by using this two value we are going to find the number of electrons. Okay, to find you have to write number of electrons. Okay, so what formula we already know? Current I is equal to Q by T. Charge by time is equal to current. Charge flowing per unit time is called what? Current. Already you know this formula, isn't it? Charge flowing per unit time is called current. Okay, so here current value they given. So first you have to write I is equal to 5 ampere equal to charge value we don't know. Okay, first we are going to find the charge. Q value we are going to find. Okay, so Q by 1. Okay, so Q is equal to what? Here 1 only there. So 5 into 1, 1. 5 into 1, 5, isn't it? Okay, so 5 is equal to Q. So Q value is equal to 5. Take this is equation number 1. Now we know Q, charge is equal to, what formula I know? The related formula, number of electron. Charge Q is equal to N into E. E be the what? Electrons. Okay, so number of electrons. Okay, so E be the value of the charge of this electron and N be the what? Number of electron. Okay, so Q is equal to Ne. N be the number of electron and E be the value of one electron. Okay, so we are going to substitute equation 2 in equation 1. Okay, so the place of Q we are going to substitute 5. Okay, so 5 is equal to N into E. Okay, 5 is equal to N into E. So 5 is equal to N into, do you know this value of 1 electron? Already we studied from the beginning of this lesson, 1.6 into 10 to the power minus 19 coulomb. Okay, so the value of 1 electron is equal to 1.6 into 10 to the power minus 19 coulomb. This value should be memorized. Then only we have to do this problem. Okay, the value of 1 electron is equal to 1.6 into 10 to the power minus 19 coulomb. Okay, that value here we have to substitute. Okay, so from this we are going to find what? N value. Okay, so next step what we have to write? Yes, N is equal to 5 divided by this value, 1.6 into 10 to the power minus 19. Okay, so then we can get what? Number of electrons. So number of electron N is equal to 5 divided by 1.6 into 10 to the power minus 19. Okay, so next step I written like this, N is equal to 5 by 1.6 into 10 to the power minus 19. Okay, usually we will take all this in the denominator value in the numerator. Okay, so this 10 to the power minus 19, if you are taking numerator it will become plus 19. Okay, so 5 into 10 to the power 19 divided by 1.6. Okay, so here the decimal number is there in the division, so we have to be changed into whole number. So how to make this into whole number? We have to multiply both the sides, multiply divided by 10. Okay, so 5 into 10 divided by 1.6 into 10. What we can get? 5 into 10 means 50. Okay, divided by 1.6 into 10 means 16 we can get. Okay, so 50 divided by 16. Okay, now we can divide, isn't it? So if you are dividing this 50 divided by 16, what will get? 3.125. Okay, just divide it and write the value 3.125 we can get it. Okay, 3.125. Okay, so 3.125 into 10 to the power 19 electrons are there in the 5 ampere of this current. Okay, so per second how many electrons are flowing? 3.125 into 10 to the power 19 electrons. Okay, how many electrons? 3.125 into 10 to the power 19 electrons. See third question. A piece of wire of resistance 10 ohm is drawn out so that its length is increased to 3 times its original length. Calculate the new resistance. See a piece of wire. What is the resistance value they given? 10 ohm. Okay. It drawn out. Drawn out means if you are stretching that wire, what will be happening? Length is increased. Okay, how much length is increased? 3 times the original length. Okay, so if the length is 1 centimeter, means if you are stretching, after stretching, that length of this wire is increased by how much time? 3 times increased by the original length. So 3 centimeter it will be increased, isn't it? So calculate the new resistance. Okay, like that they asked. Okay, we are going to calculate the resistance value. Okay, if you are increasing the length, what will be happen to the resistance? Okay, that only we are going to find from this formula, from this problem. Okay, so here what formula here we can use? Do you have any idea? Resistance value, the resistivity formula, have you remember? R is equal to rho L by A. Okay, that formula only we are going to use for this problem. First you have to write the given data. Resistance R is equal to 10 ohm. Original length, let us take L be the original length. After stretching, see first original length is L. Okay, after stretching the length is increased. How much increased? 3 times the original L. So 3L. increased length, next step you have to write 3L. Here one more thing you have to note it. When the length is increased, what will be decreased means area will be decreased. This one you already know. If you are like this one wire it is there. If you are stretching that wire, what will happen? This area will become less, okay? Because when we are stretching, if the wire is drawn out, what will happen? Automatically length increases means that area of this cross section will be decreases, okay? So this wire it will become thinner, okay? So this wide it will become thin when the length is increased. So if the length is increased 3 times, the area will be decreased 3 times, okay? So the decreased area, let us take A by 3, okay? Increased length is 3L and decreased area is A by 3, okay? So we are going to find here the new resistance value, okay? So we are going to use this formula. R is equal to rho L by A. Rho means what? The resistivity of the material of the wire. R is be the resistance. R is equal to rho L by A, okay? So R value, here they given what is the resistance of this length of this wire? 10, okay? So 10 is equal to rho L by A. Then we are going to find the new resistance after stretching, okay? This one before stretching the resistance 10 ohm. After stretching that resistance value we are going to find. So Rn is equal to, how to change this formula? Is rho into this, instead of L, this you have to write 3L, okay? Because length increased by 3 times. So rho into 3L divided by area decreased by 3 times. So A by 3, okay? So A by 3. So the new formula is rho into 3L divided by A by 3, okay? So here Rn is equal to, next step what we have to do? Rho into 3L. If you are taking this one in the numerator, 3 by A. Okay, so that only I written here 3 by A. Okay, so next step 3 3s are 9, isn't it? 9 rho L by A. Okay, 9. Just multiply. So remaining term write it, rho L by A. Now substitute this equation 1. Substitute equation 1 in 2. Okay, so what's that? Rn is equal to, the new resistance is equal to, what value is there? Yes, in equation 2, isn't it? Rho, see this much value, isn't it? Rho L by A, rho L by A, what value is there? 10, isn't it? Rho L by A value is 10. Okay, so 9 into, instead of this value rho L by A, we have to substitute this 10. Okay, so 9 into 10. 9 into 10, what's the answer? 90. So the new resistance is 90 ohm. Okay, so if the wire is stretched 3 times the original length, the resistance is increased what? From 10 to, it increased what? 90 ohm. Okay, it increased 90 ohm. Okay, this is the answer. Have you all understood? See, now you have to take your book first lesson textbook evaluation question. Till now we did not mark. Have you remember? I hope you marked, somebody marked from the guide. Those who did not mark and those already marked also, just you have to listen carefully. Okay, this one it will be useful for your half yearly examination. I thought to revise this portion once, but no time is there. So in between, if I am getting time, I will revise this lesson once again. Okay. Otherwise, in the Google Meet class, we will revise this lesson once again. Okay. So before exam, if you are getting time, we can do this. Okay. Now we have to mark this one word answers. Okay. First question: inertia of a body depends on inertia. Inertia means mass into distance. Okay, I is equal to m r square. So the inertia mainly depends upon what? Mass of the object. Okay, we already studied, isn't it? Inertia mainly depends upon what? Mass of the object. Mass increased means the inertia also will be increased. Have you remember what I mean by inertia? The inherent property of a body to resist any change in the state of rest or motion by itself. Okay, isn't it? That is called inertia. Okay, so if you are making the two object to hit from your leg, okay, that is one stone and one football. You all know that stone will have the heavy mass compared to the football. So football easily it will be what we can move easily, but stone it will be hardly we can move. Okay, so what is the reason here? It depends upon mass. Okay, so inertia of the body mainly depends upon what? Mass of the object. Option C. Second question, impulse is equal to, here many of you are making the mistake, isn't it? Impulse means that is change of momentum. It does not rate of change of momentum, because rate of change of momentum is equal to what? Force. Okay, Newton's second law, we already learned Newton's second law. In that, rate of change of momentum will be equal to what? Force. Okay, but impulse will be equal to what? Only change in momentum. Okay, so we already studied in this paragraph, impulse paragraph, impulse J is equal to delta P we will get. Okay, delta P, P means momentum, delta P means change in momentum. So impulse is equal to, don't confuse this answer, because many of your the one word questions and all, we are making the mistake here. Okay, so don't do that. Impulse is equal to change in momentum. Impulse is equal to change in momentum. Okay, change of momentum. Third question, Newton's third law is applicable for what? What's the answer? For a body is at rest, for a body is in motion, both A and B. See here, Newton's third law we will use for the body is at rest and the body is in motion. So what's the option? Both A and B. Okay, so this two states also we are using this Newton's third law. Option C is the correct answer. Then plotting a graph for momentum on the x-axis and time on the y-axis, slope, momentum, time graph gives. Okay, so momentum and time. Okay, momentum, the time graph, it gives what? Force, that is rate of change of momentum. Okay, already so this slope of this momentum time graph gives what? Okay, so here you all know that momentum means what? Rate of change of momentum is equal to force. Okay, rate of change of momentum is equal to force. So here momentum and time graph, it gives what here? Not impulsive force, acceleration, it will give what? Force. Okay, the option C. In which of the following sport the turning effect of the force is used? So where we will use this turning effect or the torque? Swimming or tennis or hockey or cycling? Yes, cycling only will use this turning effect, isn't it? When we are pedaling the cycle, okay, we'll use this turning effect, the rotating effect is used. So which is spotted? Cycling. Then the unit of G is ms per minus 2. It can also be expressed as dash. The unit of G is acceleration due to gravity value. The S unit is meter second power minus 2. You all know that, isn't it? It can also be expressed as dash. See, force is equal to mass into acceleration. So acceleration due to gravity is equal to what? Force by mass. G is equal to F by M. Okay. So here F you know Newton. The unit is Newton. Mass kilogram. So Newton by kilogram, we can write Newton kilogram power minus 1. Okay, it is in the denominator. So Newton kilogram power minus 1. Option B. Seventh question, 1 kilogram force is equal to, 1 kilogram force is equal to dash dyne, 9.8 dyne or 9.8 into 10 to the power 4 Newton or 98 into 10 to the power 4 dyne or 980 dyne. Here what's the answer? 1 kilogram force is equal to, it is given in page number 7. Okay, 1 kilogram, 1 gram of force is equal to what? 1 gram force is equal to 980 dyne. Okay, so 1 kilogram force means 1 kilogram means what? 1000 grams, isn't it? So 1000 into 980. Okay, so 1000 into 980 means if you are multiplying, you will get what? 9,80,000, isn't it? So 98, after that how many zeros you have to add? 4 zeros. So 98 into 10 to the power 4 dyne. So this option is correct. Okay, 98 into 10 to the power 4 dyne. Option C is the correct answer. Question number 8. The mass of a body is measured on planet Earth is m kilogram. When it is taken to a planet of radius half that of the Earth, then its value will be dash kilogram. See, the mass of this body, it will be remain same in every place. Okay, the weight only it will be changed. Okay, so here the option you have to write m. Okay, m is the correct answer. Option D. Next question number 9. If the Earth shrinks to 50% of its real radius, its mass remaining the same, the weight of the body on the Earth will be. The weight of the body on the Earth will be. Okay. So the remaining is same. The weight of this body on the earth will be, okay, earth shrinks to 50% of its radius. So original radius it is equal to r means if it is shrinks to 50%, reduced to 50%. So the radius is reduced by 2. So 50 divided by 100. Okay, so 100%, from that 100% it reduced to half. Okay, so we have to write the radius or dash is equal to 50 by 100. Okay, so the original radius is equal to r. Okay, so the reduced radius is equal to 50 by 100 into r. Okay, so 1 by 2 r. 1 by 2 r means r by 2. So like that we have to take and we have to do this sum. Okay, which formula we have to use? No, the relation between acceleration due to gravity and the gravitational formula, you know that formula G is equal to Gm by r square. Okay, so that answer here it is increased by 300%. Okay, so how this value 300% came here? Okay, we had to do. First, the original radius is equal to r. Okay, now if the radius is reduced by 50%, okay, so you have to take r dash equal to 50% of the original radius. That is 50% they given, isn't it? So 50 by 100 into r equal to, if you are cancelling, you know how will you get? That is 50 by 100, isn't it? So 1 by 2 will get. Okay, the 0 will get cancelled. So 1 5 is 5, 2 5 is 10. So here 1 by 2 the radius. Okay, so 1 by 2 r. So 1 by 2 r means that is r by 2. The radius divided by 2. Okay, now you have to use this formula. G is equal to Gm by r square. Okay, G is equal to Gm by r square. This is the relation between acceleration due to gravity and the gravitational force. Okay, so G is equal to acceleration due to gravity, formula Gm by r square. G be the universal gravitational constant, m be the mass of the earth, r be the radius. Okay, now if the radius is reduced to half means what is the acceleration due to gravity we have to find. Okay, then only we can find that how much percentage of this weight is increased. Okay, so G is equal to Gm by r square. Now the radius reduced means G dash is equal to what? Gm by r dash square. Okay, so Gm by r dash. R dash means here what? You have to write r by 2. So r by 2 the whole square. Okay, so Gm by r by 2 the whole square means r square divided by 2 2s are 4. R square by 4. Next step, we have to take this in the numerators. Okay, so this 4 will go in the numerator. So 4 Gm by r square will get 4 Gm by r square. Now this Gm by r square value is equal to what? Gm by r square means G. Okay, that is G. So G dash is equal to 4 into, instead of this Gm by r square, we have to substitute what? G, acceleration due to gravity. Okay, now we are going to calculate the increased percentage equal to G dash minus G divided by G into 100. Okay, so G dash after the radius reduced, no, after that we are finding, that is G dash. G be the original radius. Okay, that value divided by G into 100. Okay, now G dash what value we got? 4G. 4G minus G divided by G. Okay, 4G minus G divided by G into 100. Okay, 4G minus G, what value will get? 3G divided by remaining G is there into 100. G will get cancelled. So 3 into 100. 3 into 100 how much? 300. Okay, so how much it is increased? 300%. Okay, weight formula I know. What is the formula? W is equal to m into G, mass into acceleration due to gravity. Okay, so the weight increased by how many percentage? 300%. Then question number 10. To project the rockets, which of the following principles are required? Okay, to project, we already studied rocket propulsion. In that, two basic principle we use, isn't it? So what are the two principles used in the rocket propulsion? Newton's third law of motion and law of conservation of linear momentum. So the correct option here, how to select? Both A and C. Okay, D. Option D is the correct one. Option D. Okay. Fill in the blanks. To produce the displacement, dash is required. Force is required. Passengers lean forward when sudden brake is applied in a moving vehicle. This can be explained by inertia of motion. Inertia of motion. By convention, the clockwise moment are taken as negative and the anti-clockwise moment is taken as positive. Already we studied how to keep remember. Okay, the clockwise moment is taken as negative, anti-clockwise. Okay, anti-clockwise. Okay, how to keep this, remember this T word. Okay, T, this T, positive. Okay, positive symbol. Okay, so anti-clockwise moment is taken as positive. Dash is used to change the speed of car, gear. Dash is used to change the speed of a car, gear. G-E-A-R. A man of mass 100 kg has a weight of dash at the surface of the earth. What is the formula for the weight? Weight is equal to mass into acceleration due to gravity. Okay. So, here they given mass is equal to 100. 100 into acceleration due to gravity value, you know, isn't it? What is that? 9.8. Okay. So, if you are multiplying, you will get 980 Newton. So, mass of a man 100 kg means what is his weight at the surface of the earth? 980 Newton. Roman letter 3, state whether the following statement are true or false. Correct the statement if it is false. Question number 1. The linear momentum of a system of particles is always conserved. This statement is true or false? False. Okay. Because in the absence of external force only the linear momentum is conserved. Okay. So here you have to write the correct statement below that. In the absence of external force, the momentum of system of particles is always conserved. Okay. Question number 2. Apparent weight of a person is always equal to his actual weight. Apparent weight and actual weight, it won't be equal always, isn't it? So the statement is false. The correct statement here we are to write not equal to. Okay, here write not equal to his actual weight. Third one, weight of a body is greater at the equator and less at the polar region. You all know that the weight of a body is always less in the equator than in the polar region. Okay, so here greater you cut and write. So this statement actually have to write what? False. Okay, the statement it is false. And you have to write the correct statement here. Instead of greater, you write less. And instead of less, you have to write more or greater in the polar region. The fourth one, the turning a nut with a spanner having short handle is so easy than one with a long handle. Statement false. Okay. So what is the correct statement here? If it is having a spanner with a long handle means it will be the turning effect is easy. You all know that, isn't it? So, the turning a nut with the spanner having, here you have to write short, you have to cut it and write long handle is so easy than one with the short handle. So, comparing with the short handle, the spanner with long handle, the turning effect is easy. Okay. Question number 5. There is no gravity in the orbiting space station around the earth, so the astronauts feel weightlessness. Okay, so already we know that page number 11 it is given that statements also. So there is no gravity in the orbiting space station around the earth like that. So the statement is false. Okay, false. And correct the statement. How to correct the statement? The below that write it, space station and astronaut have equal acceleration. They are under free fall condition. So what and all you have to write? Space station and astronauts have equal acceleration, comma, they are under free fall condition. So they are feeling the weightlessness. So the astronauts feel the weightlessness. Okay, that is the correct statement. Okay, have any doubt? You have to check page number 11 once again. Okay. Match the following. Roman letter 4. Newton's first law, stable equilibrium of a body. Newton's second law, law of force. Newton's third law, flying nature of a bird. The law of conservation of linear momentum, propulsion of rocket. Okay. The next one, assertion and reasoning. Here the first question, the sum of the clockwise moments is equal to the sum of the anti-clockwise moments. Reason, the principle of conservation of momentum is valued in the external force of the system is 0. Here note this one, the sum of the clockwise moment is equal to sum of the this assertion is true, but this reason not correct explanation for this. Okay, so the correct option B. Okay, both assertion and reason are true, but the reason is not correct explanation of the assertion. Okay, right answer B. Second question, the value of G decreases as the height and depth increases from the surface of the earth. Reason, G depends on mass of the object and the earth. Okay, here the correct option is C. Assertion is true, but reason is false. Okay, the G does not depend upon the mass of this object on the earth. Okay, so the first one is G acceleration due to gravity. It won't be same for all the places. Okay, it will vary from place to place depending upon the height, depth. Okay, this value will change. Okay, but for that it is not correct explanation. Okay, this G depend here what they given depends on mass of the object and the earth they given, that is wrong. Okay, so we had to select this option C. Assertion is true, but the reason is false. Okay. Then I hope this Roman letter 6 and all already you marked, I think, in the class itself. Some questions already you marked, isn't it? Those who did not do this sum, if the third one, if 5 Newton and 15 Newton forces are acting opposite to one another, find the resultant force and the direction of action of the resultant force. Okay, so for this one you have to take F1 is equal to 5 Newton, F2 is equal to 15 Newton, and you have to find the resultant force. Okay, so resultant force, the greater force minus the smaller force. Okay, so like that you have to use that formula and you have to do it. See, first write it. F1 is equal to 5 Newton, F2 is equal to 15 Newton. The total force, net force is equal to F2 minus F1. So, F2 is equal to 15 minus 5. Okay, you have any doubt, you have to be, see page number 4. They given in one tabular column action of forces, in that formula is given. Okay, so in that you have to refer it, page number 4. Okay, so net force formula is given F2 minus F1, which is the greater force. From that force you have to subtract the smaller force, F2 minus F1. So 15 minus F, 15 minus F, you know, 15 minus F1, that is 5. So 10 Newton, answer is 10 Newton. I hope the remaining questions you marked. Okay, we have to be prepared for your half-yearly examination. Okay, so you have to prepare well for a half-yearly examination. Okay, thank you students.